Good morning all. In this class we are going to discuss about nuclear fission. First, what is nuclear fission? Which means the largest molecule split into or break into two smaller nuclei of comparable mass along with the emission of few neutrons and energy. That is called nuclear fission. In 1939, German scientists Otto Hahn and Strassmann discovered that when a uranium nucleus is bombarded with neutron, it breaks into the two smaller nuclei. First, what is nuclear fission? Please all of you say with me. The largest heavy nuclei breaks into forming two small nuclei and producing amongst few neutrons and energy. This is called nuclear fission. It was first discovered in 1939 by German scientist Otto Hahn and Strassmann. Okay. This process of breaking up of heavier nucleus into the smaller nucleus with the release of large amount of energy. Here we can see the nuclear fission image. Here we can see the image. The heavy nuclei split here. The splitting of nucleus split into form two nucleus with the release of neutrons and energy. This is called nuclear fission. This nuclear fission of uranium, here 92 uranium 235 is the fissionable material. If it is the subjected into the nuclear fission, it is split into the two small nucleus. The average energy released in this fission, nuclear fission, 3.2 into 10 to the power of minus 11 joule. Nuclear fission is pictorially represented in the following image. Here we can see the nuclear fission image. This uranium 92 is split into two nucleus with the 3 neutron released. During this time 3 neutron released and energy also released from this nuclear fission. Okay. The next one, fissionable material. Fissionable material is nothing but radioactive elements. What are they? Radioactive element, they have the capacity to radioactivity which undergo fission in the sustainable manner, which are called fissionable material, or it also termed as the fissile material. What are the fissionable material? For example, uranium 235, plutonium. These are the examples of fissionable material because they are radioactive material. All isotopes of uranium do not undergo the nuclear fission, but some of the isotopes of uranium undergo nuclear fission. For example, uranium consists of 99.28% of uranium 238 and only 0.72% of uranium 235 undergo nuclear fission. Above this two, uranium 238 does not fissionable because they do not have the capacity to radioactive and fission, nuclear fission. But this uranium 235 is the fissionable material and uranium 238 is non-fissionable because they do not have the capacity to radioactivity. But uranium 235 is the fissionable material. Okay. They are the some radioactive elements which can be converted into fissionable material. They are called fertile, but they are non-radioactive. They are non-fissionable material, but by man-made or some reactions it converted into fissionable material. These are called fertile material, not fissionable material, because they are converted into fissionable, non-fissionable to fissionable. So they are called fertile material. The fertile material example uranium 238 and thorium 232, because uranium 238 is the non-fissionable material. Some of the radioactive elements used for this non-fissionable and it converted into fissionable. So these are called uranium 238 is called fertile material, and plutonium 240, thorium 230 also comes under the category of fertile material. The next one is chain reaction. Here we can see the chain reaction. Yeah, uranium 235 when bombarded, which means affected with the neutron undergoes fission producing 3 neutrons. Here the uranium 235 when it when the uranium 235 when affected with the neutron in producing 3 neutrons. When affected with bombarded with the neutron, it producing, here we can see the 3 neutron. This neutron is the affecting neutron. Here we can see the neutron image. This neutron undergoes fission to creating the uranium fission. So these release 2 uranium nucleus and then 3 neutrons. These 3 neutrons, here we can see the 3 neutron. These 3 neutron fission in the other 3 uranium. These 3 neutron also cause fission in the other uranium. Here this neutron cause fission in this uranium and this neutron cause fission in this uranium, and this neutron also cause the fission to produce the 2 uranium as well as 3 neutron. So in the first step it producing the 3 neutron, and the second step it producing 9 neutron, because these 3 neutrons also undergo the fission with the uranium. So second step it producing the 9 neutrons. These 9 neutrons in turn may produce 27 neutron, because 9 into 3 they are producing the ratio of 9 into 3. So they are producing 27 neutrons. Likewise, this chain reaction happens continuously. So this is called chain reaction. It is the self-propagating process of number of neutrons. So the number of neutrons undergo multiplying by the geometrical progression. This chain reaction classified into 2 types: controlled chain reaction and uncontrolled chain reaction. Controlled chain reaction means the number of neutron released is maintained to be 1, because it can be controlled. It is the controlled chain reaction. The number of neutron released maintained to be controlled. This is achieved by observing the extra neutron with a neutron observer, leaving only 1 neutron to produce further fission, because it leaving only 1 neutron. For example, if it is just we have to imagine that it is controlled chain reaction, means here the number of neutrons to be produced controlled, it producing only 1 neutrons. Other neutrons are the extra neutrons are absorbed by the main uranium. Okay, so it releasing only 1 neutron, and this neutron production is maintained. But other extra neutrons are observed by the observer. Okay, it is used for further fission. Thus the reaction is sustained in a controlled manner. The energy released due to the controlled chain reaction can be utilized for the constructive purposes, because this reaction is controlled. In the other reactions, the neutron release, the neutron production is uncontrolled, but this reaction, this controlled chain reaction, producing only 1 neutron, the other extra neutrons are observed by the uranium. The energy also in the controlled manner. This energy produced by this controlled chain reaction used for the constructive purpose, because this energy is used for the sustainable manner. Okay, the next one, uncontrollable chain reaction. In the uncontrolled chain reaction means already we have discussed in the chain reaction, both are same. In the uncontrolled chain reaction, the number of neutron multiply inidentically and causes fission in the large amount of fissile material. Here we can see the uranium produces 2 neutrons. These again cause fission and again produces, this 2 produces 4, 4 produces 8. Likewise, this uncontrollable chain reaction undergoes continuously. the number of neutrons multiplies unidentically. Okay, this result in the release of huge amount of energy within the fraction of second. It produces huge amount of energy in the fraction of second. This kind of chain reaction is used in the to create atom bomb to produce an explosion. This reaction used in the create atom bomb to produce atom bomb because this condition is uncontrolled. So we produce large amount of energy from this which leads to an explosion. So this used in the atom bomb creations. Okay, this is called uncontrollable chain reaction. The next one is critical mass. During a nuclear fission process, about 2 to 3 neutrons are released. But all these neutrons may not be available to produce further fission because these producing many more neutrons, 2 to 3 neutrons. All these neutrons are not used for the further fission because some neutrons are escaped from this process, escaped from this system. These escaping neutrons are called leakage of neutrons. This process is called leakage of neutrons because some neutrons are escaped from the system because it undergoes fusion. It undergoes fission but it escapes from the system. So these neutrons are leakage of leaking neutron, and some may be observed by the non-fissionable material present in the system. These two factors lead to the loss of neutron because some neutrons are escaping, some neutrons are observed by non-fissionable material. So these two processes reducing the neutron amount in the critical mass. These two factors lead to the loss of neutron. To sustain the chain reaction, the rate of production of neutrons due to nuclear fission must be more than the rate of its loss. This can be achieved only when the size of the fissionable material is equal to optimal value. This is known as critical mass. What is critical mass? The rate of production of nuclear is sustainable for the reaction because it is lost by leaking process as well as absorbing process. So this can be achieved by when the size of the fissionable material is equal to certain optimal value. This is known as critical mass because the neutrons needed to sustain the chain reaction. The rate of production of neutron due to nuclear fission must be more than the rate of its loss because it adjusting the loss because the neutron production is more. If the neutron production is more, it easily adjusts the neutron loss. That is called as critical mass. Here we can see the example image of critical mass. The critical mass is fissile material is the minimum amount needed for the sustained nuclear chain reaction. Here the nuclear chain reaction is sustained. The fissile material is needed because the neutron is reduced by the leakaging as well as absorbing. So here the fissile material is needed to sustain the chain reaction, nuclear chain reaction. This critical mass is classified into two types, that is subcritical as well as supercritical. What is subcritical? If the mass of the fissile material is less than the critical mass, it is termed as subcritical. Here the fissile material is less than the critical mass, that is subcritical. If the fissile material is more than the critical mass, it is termed as supercritical. These are the two classification of critical mass, subcritical as well as supercritical. The next one is atom bomb. Atom bomb is based on the principles of uncontrolled chain reaction. We know uncontrolled chain reaction, it cannot be controlled. It producing large amount of fissile material as well as energy. So this atom bomb is based on the principles of uncontrolled chain reaction. this reaction, the number of neutrons and the number of fission material multiply almost in the geometrical process. It cannot be controlled. This release of huge amount of energy in a very small time interval and leads to an explosive, because it producing huge amount of energy, large amount of neutrons as well as fission reaction, large number of fission. So it used in the this principle used in the atom bomb creation. So it leads to an explosion. Here now we are going to discuss the structure of atom bomb. Here atom bomb consists of the piece of fissile material whose mass is subcritical. Okay, this piece was a cylindrical void. Here we can see the cylindrical void. It is the fissile material. Okay, it has the cylindrical fissile material which can fit into the void, and its mass is also subcritical. Here this mass, the fissile material mass, is also subcritical. When the bomb has to be exploded, this cylindrical is injected into the void. Here when the bomb is exploded, that the time the cylinder is the inside we can see the cylinder. This cylinder is injected into this void. This green part is the void. That time the cylinder is injected into the void using a conventional explosive. Now the two pieces of fissile material join to form the supercritical mass. Here this piece, the green piece and the center grey piece, fused together to create the supercritical mass, which leads to an explosive. The structure of atom bomb is here we can see the cylindrical target as well as hollow uranium bullet. This uranium bullet is hollow and the cylindrical target. Okay, during the explosion, tremendous amount of energy is produced from this atom bomb. Here we can see the tremendous amount of energy is produced from the atom bomb. A region of very high temperature and pressure is formed in the fraction of a second. It forms a huge amount of energy, temperature as well as pressure in a fraction of second. So it is very hazard to the people. It is very harmful to the people because it producing harmful radiation like gamma rays, which adverse affect the living creatures, which producing the adverse effect to the living creature. This type of atom bombs were exploded in 1945 in the Hiroshima and Nagasaki in Japan during in World War II. That time this type of atom bombs was used to create exploded, okay, in 1945. Thank you all.